easy go.
Hello everyone, my name is Alius and I am a third year electrical and electronics engineering student at İzmir Katip Çelebi University. Today I will be demonstrating my bare metal implementation for the laboratory assignment 3, real-time sensor data acquisition. Let's start with the hardware setup. I am using an STM32F07 discovery board. For the analog input, I chose an NTC Thermistor, which is a temperature-dependent resistor. Since the microcontroller's ADC reads voltage, not resistance, I built a voltage divider circuit using the thermistor and 10 kΩ fixed resistor. The node between them is connected to pin PA1. Because I am using F407 discovery board, the UART pins are not internally connected to USB like on nuclear boards. To solve this, I integrated a CP2102 USB to TTL converter. I connected the PA2 pin, which is configured as UART2TX to RX pin of the converter. I ensured a common ground between the two boards. Now, let's examine the bare metal ADC configuration used to read thermistor's voltage. To begin, I enabled the system clocks for the port A and the ADC1 variable using the RCC registers to ensure the hardware is powered. Next, I configured the pin PA1 into analog mode via the mod R register. This is a crucial setup because it disables the digital input buffer and allows the pin to capture continuous voltage variations. Since PA1 is physically connected to ADC channel 1, I wrote the value 1 to the SQR3 register to set it as the primary target in our conversion sequence. Because our system requires real-time temperature monitoring, I activated the continuous conversion mode by setting the count bit on the CR2 register, which forces the ADC to automatically loop its reading without CPU intervention. Finally, with the setup complete, I powered up the ADC module using add-on bit and pulled the software trigger using CW start bit launch to continuous measurement cycle. Moving to communication side, I configured UART to transmit our data to PC. First, I enabled the UART2 variable clock via the APB1 enable register. Next, I set PA2 alternate function mode in the mod R register and specifically routed the UART2 by writing value 7 into alternate function register. To meet the assignment's exact requirements, I calculated the baud rate register value for 115,200 bits per second based on 16 MHz system clock, which resulted in the hex value 0x008B. Finally, I activated transmitter and the entire UART module by setting the TE and UE bits in control register 1. Making our hardware fully ready to stream data. Now, let's look at the main loop and the live demonstration. Inside the infinite loop, the system constantly pulls the end of conversion flag in the status register to capture the raw 12-bit ADC data. To calculate the actual voltage, I simply multiply this raw value by our 2300 mV reference and divide it by the maximum 12-bit resolution of 4095. I then transmit this formatted string showing both the raw count and the calculated millivolts to the computer using the redirected printf function. As you can see in the live terminal, the data stream updates smoothly every 100 milliseconds. When I touch or release the NTC thermistor, its physical resistance changes. And you can see instantly observe the millivolt readings rise and drop on the screen, providing the real-time reliability of our bare metal data acquisition pipeline. This is how the system looks in the real life. We have an NTC thermistor here, 10K ohm resistor. This is the USB to TTL converter, and you can see the values here. When I touch the thermistor here, you can see the voltage values rising, and when I left the thermistor, you can see the values are dropping down. To summarize, I have successfully built a complete bare metal data acquisition pipeline. The microcontroller reliably reads the continuous analog voltage from the sensor circuit using the hardware ADC, processes the data, and streams it to PC via UART at exactly 115,200 bits per second without using any HAL libraries. This concludes my laboratory demonstration. Thank you for watching to me.